Institute of Engineering and Technology.
Hello students, good morning. Today we are going to consider higher order differential equations, and in general solution we are considering complementary function with part 2. In my last video I covered first part in which complementary function was derived for auxiliary equations with real and distinct roots. You should refer that video first if you haven't gone through it yet. So in this part, we are focusing on real and repeated root. What will happen if auxiliary equations are giving real and some repeated roots? How to derive complementary function? Let us see. So you can see over here again, let us consider our usual way of defining higher order differential equation for second order. So for simplicity, I am considering second order differential equation, which is y double dash plus c1y dash plus c2y equals to r of x. As usual, here function y is depending on independent variable x. C1, C2 are arbitrary constants, and r of x is a random function of variable x. We are defining this equation with help of differential operator d raised to n. Capital D raised to n is nothing but nth order derivative of y with respect to x. This will make many things easy for us in higher order differential equation. So if I consider this operator d, then my second order differential equation will take this form: d square y plus c1 times dy plus c2 times y equals to r of x. Then considering y outside the left hand side, it gives me d square plus c1d plus c2 times y equals to r of x. And this will let us consider operator form of given differential equation, which is f of d times y equals to r of x. This will be my first step in this method. Now to consider complementary function, we are focusing on the left hand side of given equation, and by considering f of d equals to 0, we'll get auxiliary equation, or is also known as characteristic equation. Once we have this auxiliary equation, we can take regular factorization on the left hand side and we can identify roots of this equation. While finding roots of this equation, we will receive four possibilities. It may happen that these roots are real and distinct, these roots are real and repeated, these roots are complex and distinct, and these roots are complex and repeated. In this talk or in this video, we are going to consider case 2 of real roots, which is real and repeated roots. So what will happen if I consider auxiliary equation f of d equals to 0, and if I consider the roots of this equation, which are m1 and m2, and they are real as well as repeated. So it is actually m1 equal to m2. So in such cases, we need to consider complementary function in this way: c1 plus c2 times x into e raised to m1x. You should always remember one thing while finding complementary function, that the total number of arbitrary constants in any complementary function are always equal to order of given differential equation. So as given equation over here, the second order differential equation, I need to write this complementary function as C1 plus C2x. What will happen if my auxiliary equation is of order 3? In that case, if I will add 3 repeated roots, m1 equal to m2 equal to m3. So in such case, we have c1 plus c2x plus c3x square bracket into e raised to m1x. This is how you can deal with repeated real roots in case of auxiliary equation. Now let us go through some examples. First example is to figure out or to find complementary function for this equation y double dash minus 4y dash plus 4y equal to 0. Now here the given differential equation is d square minus 4d plus 4 into y equals to 0. This is operator form of given differential equation. Now to consider complementary function, let us take f of d equal to 0, which is an auxiliary equation, and that gives d minus 2 whole square equals to 0, as this is the perfect square, and that gives us m1 equal to m2 equal to. So this 2 is the real and repeated root. Now let us consider this real and repeated root into our complementary function. So one constant is for m1 and one constant is for m2. And as our root is repeated and it is 2 times, so it is c1 plus c2x into e raised to 2x. This is how you can find complementary function for 2 repeated roots. Let us consider second example. Equation over here is y cube minus 5 times y double dash plus 8y dash minus 4y equal to 0. So the operator form of equation is d cube minus 5d square plus 8d minus 4 times y equals to 0. And therefore auxiliary equation is f of t equals to 0. Now if I consider the operator form, then auxiliary equation will turn out to be d minus 1 into d minus 2 whole square equals to 0. And that gives us roots m1 equal to 2, m2 and m3, they are real and repeated roots with value 2. Again, let me remind you that there is no rule for the order of roots. You can take m1 equal to m2 equal to 2 and m3 equal to 1 also. It won't make any difference in your final answer. But now, as I assumed here m1 equal to 1, so the first part is as real and non-repeated, like c1 e raised to x. And then 2 roots are repeated. So I am following the rule of real repeated roots. So it is c1 plus c2 plus c3x into e raised to 2x for this 2. This is how you can deal with the combination of some real roots which are repeated and non-repeated by nature. Let us consider one more example. Suppose I have this equation y raised to 4 minus 2y cube plus y square equals to 0, which converts like d raised to 4 minus 2d cube plus d square y equals to 0 in operator form. And then if you take auxiliary equation f of d equals to 0, then finally the factorization will let you d square into d minus 1 whole square equals to 0. And that finally gives you 2 roots 0 and 2 roots equal to 1. That means now we have 2 pairs of repeated roots. The first pair, or you can say the first 2 roots are repeated with value 0, second 2 roots are repeated with value 1. And so let me take the first part with root 0. So it is c1 plus c2x into e raised to 0x, which will eventually turn to be 1. Second is c2 plus c3x into e raised to x. Here I am taking constant part. Again, as I told you earlier also, you can take this as the first pair and you can take this 2 as second pair. So this is how you can deal with real roots which are repeated by nature, and it may happen that your roots are coming along with some non-repeated roots also. Let me consider one more example. Here you have y raised to 4 minus 6y cubed plus 12 times y square minus 8y raised to 1 equals to 0. Considering the differential form, it gives us d raised to 4 minus 6d cubed plus 12d square minus 8d y equals to 0. Considering complementary function, so auxiliary equation is f of d equals to 0. Now, considering the left hand side and factorizing it will give you d into d minus 2 whole raised to 3 equals to 0. Which simply means that we have one root by this part which is 0 and 3 roots by this part which is repeated and with value 2. So how to write down complementary function for this case? I am writing c1 into e raised to m1x. Now value of m1 is 0, so it is c1 into 1. I am writing second part for this repeated real root with value 2, which is c2 plus c3x plus c4x square into e raised to 2x. This is how you can deal with 3 repeated real roots. Now you can generalize this method for any number of real and repeated roots. For instance, if I consider that in this case only we have one more root which is equal to 2. So what will happen? You will get m1 equal to 0, m2 equal to m3 equal to m4 equal to m5 which is equal to 2. So in that case, if you have 4 times real repeated root, the corresponding component of complementary function would be c2 plus c3x plus c4x square plus c5x raised to 3 into e raised to 2x. So this is how you can consider any case in form of real and repeated roots. I hope you understand this whole consideration of real and repeated roots. So if you have any difficulty, you should again go through the video. You should pause and ponder in between, and you can always check where there is a case of real and repeated roots and real and repeated roots with some non-repeated roots. And also take care that what to do in case of repeated roots with more than 4 or 5 multiplicity. Thank you.
LJ Institute of Engineering and Technology.